Hello everyone, welcome to Rubber Industry NewsHour. This is a weekly program for rubber industry, and it is managed and owned by Technobase, and it happens on every Monday. Let me brief you about Technobase, and I think many of you know already what is Technobase means, and let me quickly introduce what are the activities that we are doing as a part of the Technobase. Technob is based in Thailand and established in 2005, and it is recognized as International Resource Center for Industries and Technologies. The main services of the Technob is involved with the professional education, and along with that one, we have a business service. When it comes to services, it's pretty much global. We do organizing exhibitions, training and conferences, webinars, we have publications and talent search and skill development, also marketing and branding, various issues related to these are the business services, and also we have the professional education. And when it comes to the business focus, we have two segments, polymer industry and non-polymer industry. When it comes to the polymer, rubber industry, plastics, polyurethane, adhesives and coatings, chemical and technology and engineering. We also have the non-chemical side. We energy, environment, water and membranes, filtration, separation. So these are the areas that we cover in terms of the business. As I mentioned to you, we provide a global service. Let me brief you about what kind of activities we do for the rubber industry. We have an exhibitions. One exhibition is next year we are doing in Bangkok, GRTE 5th edition. We also have an exhibition, Arab Rubber Expo, which is scheduled next year in November. We have online training programs, number of online training programs. You can check the details about this online training program in documents that you can download from the handout section. We call NewsHour webinar platform, which we offer online training programs. We have 40+ well experienced and knowledgeable experts as a resource person offering various topics on the rubber technology. We have three types of programs, short topics, 30 minutes to 3 hours long. We develop around 250 short topics. We also have master classes, 20+ master class available. And also we're introducing next year a 3 months program, diploma program as well. This is a diploma program next year. We also offer the skill development if a company is interested to improve the skills of their team. So we have the program there. We have lots of books on there for the rubber industry. You can check out Technobase store, store.technobase.org. We have 50+ reference books are there. And we have a magazine called Rubber and Tire Digest magazine, which is a bi-monthly magazine. Free to subscribe. It's available on rubbertiredigest.com. And this is a NewsHour program. Every week we organize on every Monday to keep updated. And also we have this Rubber Industry Connect program, which we introduce and brand the company through the Technobase social media platforms, which will have the both company presentation as well as the business interview. We offer customized marketing, for the companies who want to promote their business. We also have various professional networks. Facebook, we have a Rubber Technologies global network. Currently, we have 5,000+ members are there. We have the Rubber Industry Network on the LinkedIn. I think currently is 4,500 members are there. We also have WhatsApp group. I think it's 3,000+ members in the WhatsApp group related to rubber industry. We have platform, video platform, which we operate on YouTube at Technobase channel. And this session, Rubber Industry NewsHour, it's will be available on YouTube on every Monday. If any information you need, you can always contact me for additional assistance you need. Okay, that's briefly about Technobase and what we are doing. Let's get to the today's episode. Episode number 25, Rubber Industry NewsHour, and today is 4th July, and for all the American friends, happy Independence Day. Welcome you all. Sawadee krap. What are the highlights of the today's episode? We have two main things today. First, we'll have the natural rubber market outlook by Mr. Jom Jacob. He's a rubber industry analyst. Then we will have the technical talk, the rubber industry tech talk, which is focusing on the latest developments in mold releasing agents and odor absorbents for rubber industries by Colin Clark. He's a director of the technical services Stuttgart. In this session, after his presentation, we have two eminent rubber technologists. They'll be joining Colin to have a discussion about the mold release agents and also the odor issues in the rubber industries. Mr. E. Palarinathan, and he's a rubber industry consultant, and also Dr. Han Joachim Graf, both of them joining in the discussion session after the Colin's presentation. So that's the highlights of the today's episode. So let's get to the first session, let's say on the natural rubber market outlook. Let me introduce about Mr. Jom Jacob. He has more than 30 years experience as an rubber industry analyst with extensive experience in the analyzing rubber markets, forecasting industry trends, and formulating long-term policies and development plans for the natural rubber sector. So let's welcome Mr. Jom Jacob to give a update on the natural rubber market outlook.
Hello everyone, welcome to Natural Rubber Market Outlook, episode number 25. As usual, we will begin with a brief overview of the prices prevailed in the markets during last week. We have a PowerPoint slide that is summarizing the prices during last week. On the left side, we have the average prices of rubber futures traded on the Shanghai, SICOM, and JPS Osaka exchanges. So last week, that is a week ended 1st of July, rubber futures traded on the Shanghai exchange averaged 1.3% higher, and SICOM TSR20 averaged 1.2% higher, and at JPS Osaka, RSS3 futures averaged 1.0% higher. Coming to physical markets, so there is one correction to be done at on the title of the second column. It is week ended July 1st. By mistake, I put both titles of the column titles same, so it should be week ended July 1st, second column. So STR20 physical market Bangkok averaged 2.0% higher during last week compared to a week before. SMR20 Kuala Lumpur averaged 1.3% higher. RSS3 Bangkok averaged 1.2% lower. RSS4 Kottayam averaged only 0.1% higher. Latex Bangkok averaged 2.4% lower. Latex Kuala Lumpur averaged 4.4% lower. That means, except in the case of RSS and latex grades, prices have been marginally higher during last week compared to a week before. So now let us examine how the prices are going to perform in the short-term future. So we have to analyze the demand side, the supply side, and also what is called this developments in the futures market in terms of risk appetites. So coming to the demand side, we have some positive factors, positive news this time. One, as we know, China have been adhering to strict anti-COVID measures. This is in sharp contrast with the other countries which have already adopted a policy like living with COVID, because people are vaccinated. So almost all restrictions were withdrawn, lifted, and except China, all countries are actually living without restriction. So that was a policy followed by all other countries except China. But China have been following strictly adhering to strict anti-COVID measures, and such a policy, complete lockdown and other various other restrictions, have impacted on its economy as well as businesses. But giving a major relief in a major easing of COVID-19 curves, on 28th of this June, last month, June, China slashed the quarantine, the mandatory quarantine time at the centralized facilities for inbound travelers. It was 14 days before earlier. Compulsory quarantine for inbound travelers was 14 days before earlier. Now, effective from 28th of June, it is 7 days. So there's a major change, a major easing of COVID restriction. Another change, after this 14 days centralized facilities, inbound travelers were required to undergo a subsequent health monitoring at their home for 7 days. So that 7 days at home subsequent health monitoring period has been reduced from 7 days to 3 days. So these two important changes China has introduced effective from 28 June, and that is a major positive news to the manufacturing activities as well as business sentiments within China. So major economic hubs, including financial capital Shanghai, emerged from the virus lockdown. So this is a major news for China's business sector and economic activities. Another important factor, another important important positive news is with regard to China's manufacturing sector, manufacturing activities. There is a measure called PMI, Purchasing Managers Index, which is measuring the manufacturing activities. If PMI is 50 above, more than 50, it means manufacturing activities have expanded. If PMI is below 50, it means manufacturing activities in the countries have contracted. So in June, in spite of the COVID restrictions there, China has posted a PMI, which is manufacturing PMI, which is above 50, that is 50.2. So in fact, this China's PMI was below 50 the previous months, that is May. So in May, manufacturing was contracting, but in June, manufacturing activities expanded. But in spite of even though it is above 50, expectation of the market was 50.5. So against the expected reading of 50.5, the PMI stood only at the 50.2, but still it is a positive news, although it is below, it missed the market expectation. Another important news from China. China imported 2.22 million tons of natural rubber. I mean, natural rubber includes, because China import a lot of compound rubber and mixture rubber because of the advantage in the payment in the form of import taxation. China imported 2.22 million tons during the first 5 months of this year, and this quantity is 5.7% higher compared to the same period in the previous year. So in spite of these COVID restrictions and a strict lockdown, this is a import figure. Not only, when we look into the countries outside China, all the major consuming countries like India, US, European Union, Malaysia, they all reported a positive, an increase in the import of natural rubber during the first 4 months of this year, January to April. For example, India imported nearly 217,000 tons of natural rubber during January until April, which is 4.4% higher compared to the same period in the previous year. US imported nearly 400,000 tons of natural rubber, which is 12% higher compared to the same period in the previous year. European Union EU bloc imported nearly 450,000 tons of natural rubber, which is 2.1% higher year on year. And Malaysia, even though Malaysia is a producer, Malaysia imports a lot of natural rubber, especially capelum and latex, to cater to its SMR factories and glove manufacturing industry located in the country. So in the case of Malaysia also, there was a 3.2% increase in the import. So higher import means there is higher demand compared to the same period. So the demand performed better during January to April in the case of non-China countries, consuming countries, because for these countries we have figure only up to April. But in China, we have the figures up to May, which is also higher. So demand performed better during the period until now this year compared to the year before. But that is a positive factor. At the same time, we have this the fear of a global economic recession looming large. That means the future of rubber demand is not bright. So that means global demand outlook for natural rubber is weighed down by the growing risk of a global economic recession. So recession has not yet started. According to technical definition, a recession is reported as the recession has begun only if a country or global economy posts 2 consecutive quarters of contraction. That means that there should be minus economic growth for 2 consecutive quarters. Then only it is termed as a recession. So that means that the recession has not started, but players in the market are expecting, now they are concerned about fear about global recession that may be coming at the beginning of next year or the last quarter, still not known. And another negative news, demand for natural rubber latex is coming down world over. So when earlier we have seen import of natural rubber has increased in the major consuming countries, but if we look into the import of natural rubber latex alone, the earlier figure was with reference to the whole quantity of natural rubber. But when we look into the import of natural rubber latex alone, it is coming down in all the above countries. That means demand for latex because of the less demand for rubber glove due to the prevailing COVID situation, there is a less demand for rubber glove, and because of the same reason, demand for NR latex has come down, and we have earlier seen latex prices have come down in both in the Bangkok as well as in the Kuala Lumpur market. So this explains why latex price came down, because imports of natural rubber latex has come down in the major rubber latex consuming countries. So this is a development demand side. We have China situation improving, that is on one side, but on the other side we have the risk of global economic recession looming large. There's negative news. And also the latex demand is coming down, that is also a negative news. So this is a situation with reference to the demand sector. Now let us see how the supply side is likely to perform, or what is the current scenario in the global NR supply. So as I mentioned in the previous episode, from now onwards until end of this year, that is December 2022, is a season of high world supply. That means a seasonal factor can keep global supply high till the end of this year. The supply is there. However, there are a few factors which can constrain the supply to a limited extent. So one factor is, in the case of Indonesia, nearly 70% of Indonesia's rubber growing region is in the south of the equator. So for that particular region, the wintering off season is July August, September, July to September. So because of that reason, Indonesia's production will be lower for the next 3 months. So less production supply will be available from Indonesia for the next 3 months because of this seasonal factor in that specific to Indonesia. Indonesia has a specific seasonal pattern which is different from the countries for which the rubber growing regions are mainly in the north of the equator. Another factor, nearly 0.4 million hectares of rubber trees in Indonesia have been infected by the new leaf spot disease called pestilopsiosis, fungal leaf disease. And for this 4.4 million hectares of rubber trees, yield will be low because of the negative influence of the disease. Then another factor which can hinder the world supply is the rains, which can disrupt the tapping. And so these are some of the factors which can have a negative influence on the global supply. But at the same time, we have to take into account that global supply will be high until January. Although we have a few factors which can have some negative impact on the global supply to a limited extent. So we have one side, we have demand, and we have now supply side. Now we will see what are the other factors which can influence the price in the short term. Of course, sentiment is very important for rubber, for commodity market, and natural rubber is no exception. Now, the risk appetite is expected to remain low in rubber futures. Means what is the risk appetite? The willingness of the speculative investors to invest in risky assets. So the investors will be, the risk appetite will be very high. That means that they are willing to take risk. At the moment, risk appetite is low. Why the risk appetite is low? That risk appetite is low means the speculative investors are likely to stay away from risky asset classes like rubber futures or commodity futures and also equity markets. They prefer to stay little away from the risky asset. So this situation is called a less risk appetite situation. One reason, global economic recession warnings are looming large. That is mainly because of the aggressive policy. The term mainly used by technical term being used for that is a hawkish stance, means aggressive policy. So because of the aggressive policy approach taken by the US Federal Reserve and other central banks across the world, the possibility of an economic recession is looming large. So the priority for the central bank is to tame or to combat the global inflation or the inflation in the respective countries, even at the cost of a recession. So priority is now to combat or to tame the inflation, even at the cost of a recession. So all major central banks have adopted this approach, and US central bank stand is very clear. And other central banks are also, almost all the other countries, other central banks have adopted such a stance. So that means the global economic recession warnings are looming large. So when there's a global economic recession, obviously speculative investors will keep away because of the negative sentiment arising from a recession. For the US Federal Reserve, as I mentioned earlier, the top priority is fighting inflation, even at the risk of recession. This was clearly mentioned by the Federal Reserve Chairman in the press meet immediately following the last policy meeting. And the prevailing unfavorable climate for risky investment is fueling sell-off across equity market as well as in other risky asset classes world over. Other risky asset classes means commodity market, and also there are so many other asset classes which are considered as riskier. So when there are more risk, speculative investors will stay away. Not only they stay away, they will be switching over from risky asset classes to safe haven dollar. So at the moment, we can see sell-off in the equity market and other risky asset classes and switch over to a safe haven dollar. And because of that, dollar has edged up further up. Dollar is stronger. Again, dollar is becoming stronger every day. And the dollar index is currently ruling very close to its 20-year high. Dollar index is a dollar's value against six major currencies, rival currencies, which include euro, UK sterling, Japanese yen, and Canadian dollar, Swiss franc, so many other currencies, six currencies. So dollar strength against the six currencies, rival currencies, are now prevailing at a 20-year high. A strong dollar has different meaning. First of all, a strong dollar means speculative investment is less attractive. A strong dollar means they have to for the overseas investors, for them the cost of investment is higher or the return on investment is not attractive. So at the moment there is strong dollar is hindering or dissuading speculative investors from risky asset classes, including natural rubber. So that means the prevailing situation does not encourage buyers into rubber futures. So summarizing all the three, we have the final slide. We have the final slide, which is summarizing what can expect. What are the key takeaway from the based on the 4 slides earlier. So on one side, the improving manufacturing activities in China can be a positive factor because China is accounting nearly 42% of the global demand for natural rubber. So from the end of June onwards, China's manufacturing activities are expected to perform still better. June it was good, it was 50.2. It is likely to perform still better because of the improving COVID situation and also further lifting of the restriction. So we can expect a better demand from China. So this is a positive factor. So this can have some kind of gain in the market. China factor can contribute some kind of a gain in the markets. However, the gains will be limited. There are 3 factors which are likely to limit the gains in the prices arising from the China factor. First factor, as I mentioned before, global demand outlook of natural rubber for 2022 and 2023 is weighed down by fear of another global economic recession. Recession has not started yet, but it can start maybe at the beginning of the 2023. So that is a demand outlook is not favorable at the moment. Second factor, seasonal factor, can the supply relatively higher at least until the end of the year. Third factor, as I mentioned, as we discussed earlier, the risk appetite will remain low. That means the prevailing condition will not attract buyers in rubber futures market. So this is a summary. Putting it together, we can say that we can expect gains in the prices in the short term because of the China factor, but the gains will be limited due to the factors, negative factors or dissuading factors mentioned here. Thank you very much, and we will see you again next week at the same time. Thank you.
That's the natural rubber market outlook by Mr. Jom Jacob. Before we move into the next session, let me introduce some of the rubber industry events, upcoming events happening, and invite you all to participate as per your convenience. The first event is Rubber and Tire Vietnam 2022, which will be happening on during the 3rd to 5th August in Ho Chi Minh City in Vietnam. Let me show you a short presentation on the Vietnam Rubber Expo. That's presentation on the rubber and tire Vietnam during the 3rd to 5th August. Welcome you all to participate in this event in Vietnam. The other event I'm going to introduce you is in Malaysia, IRICE. It's organized by Malaysian Rubber Products and Manufacturing Association, International Rubber Industry Convention Expo, which will be happening on 6 to 8 September in Kuala Lumpur at KLCC Convention Center. And we'll be having a rubber industry conversation session with some of the leading Malaysian rubber product manufacturers in the future episodes of the Rubber Industry NewsHour, so that you get update on what is going on in Malaysia in respect to the rubber industry. At the same time, there is another event, IRCO, organized by, it is called RubberCon 2022, and it's organized by the Plastics and Rubber Institute of Malaysia. It's at the same time during the Malaysian Rubber IRICE. This RubberCon is focusing on the new developments in natural rubber. So you can check more details about this event. It's conference, so rubbercon2022.com. Please check the details at this website. I'd like to introduce about another event, IRC 2022. It's going to happen in India and Bangalore during 24 to 26 November, organized by the Indian Rubber Institute, which is the International Rubber Conference and Exhibition. Let me show you a short presentation on the IRC 2022. That's a presentation on the IRC 2022. I invite you all to participate in this event in India during 24 to 26 November, organized by Indian Rubber Institute. You can check more details about this event at irc2022.com. I have introduced you my Technobiz exhibition, so it will be happening next year, GRTE 2023, which will be 29 to 31st March next year in Bangkok at Bitech. We also have another event, Arab Rubber Expo, focusing on the Middle Eastern region, which is going to be during the 21st, 22nd November in 2023 in Sharjah at the Sharjah Expo Center. So these are our Technobiz exhibitions. I welcome you all to participate in our exhibition next year. Okay, Rubber Industry Tech Talk. Rubber Industry Tech Talk is basically a program as a part of the Rubber Industry NewsHour, where we invite an expert to talk about the latest trends in the rubber technologies. Today, in our session, we're going to focus on the latest developments in mold release agents and odor absorbers for rubber and tire industries. This presentation will be given by Mr. Colin Clark. He is the Director of Technical Sales at Stuttgart, based in Germany. To give you a brief intro to Colin, Colin has been in the rubber industry for more than 40 years and with Stuttgart in various positions for the last 33 years. So he'll be giving a presentation first, and after his presentation is over, we have two well-experienced rubber technologists, Mr. E. Paladinathan and Dr. Hans Joachim Graf. Both are well-experienced rubber industry consultants. They'll be joining a discussion session about this topic after the presentation of Colin Clark. So let's invite Colin to make a presentation on the topic. Okay, Colin, it's all yours now.
Okay, thank you, Param. Thank you for the nice introduction, and yeah, welcome everybody. Thank you for joining or accessing my presentation. So today I'd like to talk about two different topics. The first topic will be to talk about mold and mandrel release agent. And in terms of mandrel release agents, we're talking a little bit about the shaped hose products where we'll need a more complex mandrel to form those shapes. And later on to talk about the need for absorbing odor and other VOCs in rubber and other polymer articles, and some of the technologies available for us to do that. Next, please. So this is a presentation prepared by myself with Schillen Silacker Structal, the company that I work for. The first slides that I'd like to share with you are a little bit of an introduction to the company for those of you who are perhaps not familiar with us. Next, please. So Schillen Silacker is a well-established company. We can trace our roots back as far as 1877, where we started initially in the leather industry. Our rubber additives business, our polymer additives, process additives, can be traced back to the early 60s. And more lately, we founded, expanded and created several different companies, both in Europe and also in the US. And today we operate as a corporation with 5 production sites and a little over 1,000 employees globally. Next. So these are our production locations, and today I'll talk to you about products coming from our Hamburg, Germany site. For us, the Hamburg site represents the lead site for our rubber additives and associated business units, where we produce also the release agents, some latex additives, as well as other allied industries. But we have a variety of sites, both in Germany and a couple of sites in the US, also producing additives for a variety of end user applications. Next, please. Yeah, so to the first part of the presentation, to talk a little bit about release agents. And we know that rubber molding involves a lot of resources and consumable items, and certainly generates cost and a number of waste streams. The control of mold fouling is important, and of course this would trigger additional cleaning cycle and associated downtime connected with the cleaning of molds due to the mold fouling. We have costs associated to mold fouling, of course. That's the mold cleaning itself, the use of additional consumables such as the release agents, and the disposal of mold deposits are also side streams that we must take aware of. And here I'd like to talk about so-called semi-permanent mold release agents, and later to go on, as mentioned, to talk a little bit about the mandrel release agents and the technologies associated with hose production. Next, please. So in terms of mold release coatings, actually mold release coatings are not new. We've probably used mold release systems for as long as we've molded rubber. Initially, they would be very simple mold release agents, and they could be as very basic as soap solutions or simple waxes applied to the mold to provide some kind of slip and release action. Later on, and still today, silicone emulsions are quite widely used in order to provide that lubrication and break the surface tack or adhesion, if you like, between the rubber and the mold substrate. All of these simple release agents could be considered as sacrificial layers, and that means that they're not really bonded to the mold surface. They spread relatively unevenly across the mold surface and provide some kind of lubrication and release site. However, they transfer quite often to the rubber article and need to be reapplied very frequently. And as such, they're also responsible for the buildup of mold fouling. Quite often, the surfactants or the dispersing systems used in these simple products contribute to mold fouling by virtue of the fact that they also degrade during the high temperature used for molding. So in a way, the very release agents that we use to protect the mold or to improve the release from the mold can act to contaminate the mold surface and accelerate the degree of mold fouling. On the other side, then we could see perhaps coatings that would be considered to be very permanent. So these would be processes carried out quite often offline on the mold. So things like surface coatings, perhaps chromium plating or some kind of plasma deposition technique to treat the mold almost once for its lifetime to modify the surface of the mold to prevent sticking. Alongside that, then we can think about the so-called semi-permanent coatings. And this is a very interesting area where we can extend the lifetime of the mold between cleaning by applying a reactive coating onto the surface of the mold in order to prevent the buildup of mold fouling, to really seal the mold and to have an almost inert coating that prevents then the adhesion and subsequent fixing of the mold deposits onto the surface of the mold. So really we can contrast the very simple release agents, which can contribute to also to mold defects, as you see in the picture, with the permanent and semi-permanent, as we would talk about here, much more durable and longer lasting coatings. Next, please. So in terms of the effect that we want to achieve with the mold coating, if we look at the, if you like, almost a map, or if you like, or a model, a depiction of the surface, the micro surface of a mold, we can see even a very polished and flat mold will have micro levels of porosity and surface irregularity. There are sites of high energy level, both in terms of physical keying, so interlocking of the mold and the mold deposits into the undercuts that are present on the mold, and active sites, if you like, from the metal ions that are present on the surface of the mold that allow chemical interactions to occur with those mold deposits. The target with any mold coating is to fill in, if you like, these voids to produce a more regular surface, a lower surface energy, a flatter and smoother surface as depicted by the red infill that we would achieve by a coating. And particularly with the semi-permanent coatings, the idea is to cross-link this red layer to provide a very durable and low energy coating to the surface of the mold. Next slide, please. One of the easy ways that we can see this, or one of the best ways to demonstrate this, is if we look at a coated metal plate. So on the top right of the slide here, you see a metal plate that has been 50% coated with the permalise coating. So the bottom diagonal left of the metal plate has a permalise coated surface applied to it, and the slightly lighter, perhaps a little more shiny surface is the uncoated mold surface. If we then analyze right across the boundary layer using a microscope technique like AFM, atomic force microscopy, in friction mode, so to really measure the energy levels across the boundary layer, we can see on the left-hand side, the uncoated mold surface produces quite a few high energy peaks. So there are definitely areas where there would be increased friction and interactions between the rubber and the metal surface. By contrast, on the right-hand side with the permalise coated surface, the energy levels are much more consistent and lower. So we have a very smooth, flat, low energy surface, a more or less more inert surface, if you like, where we can see a lot less potential for buildup or interactions and subsequent buildup of mold deposits onto that surface. Next slide, please. In our laboratory, we've developed a couple of different methods for evaluating mold coatings, and I'd like to share the information regarding these with you. This is a little bit of a busy slide, so I'll talk it through with you. Firstly, we have method 1 on the left-hand side. This is using a mold called the spider mold, and you can see the spider mold in the bottom half of this left-hand side image. It's a mold which has a quite extensive and uninterrupted flow path. It's designed here as an injection mold, although transfer versions are also available. And the idea is that you inject into the central part of the cavity, and then the mold flow continues around the flow paths, the so-called spiders, if you like, the legs of the spider, and we can measure the degree of mold flow achieved by that. What we do is to coat the clean mold with our mold release coating, and then inject into the mold. And of course, one of the first things that a good mold coating should do is provide a greater flow property, so to reduce the surface friction and allow a more extensive flow to occur. And so typically we would expect to see a greater molding, a greater degree of mold flow, as can be depicted by the 2 black spiders, if you like, that we can see there. One with permalise, our mold coating system, and below with a less degree of mold filling, mold flow, without a surface coating. What we can do is carry out a number of injection cycles on a cleaned mold, and this of course will allow us to not only rate the degree of mold filling, but also then subsequently measure the degree to which the mold has become fouled. One of the ways that we can do this is after making a number of injections, let's say 20 injections with our compound to create mold fouling, we can then switch to a mold cleaning compound. This is the white compound that you see next to the 2 smaller spiders. And this compound is designed to carry out a chemical cleaning action during the curing of the mold. So we would inject the cleaning compound, allow the compound to cross-link, and then remove the cured compound together with the mold fouling. And you can see where the molding changed direction on the leg of the spider and where the 2 streams flow together, that we can see some black spots that have been removed. And this is indeed mold fouling picked up by the chemical cleaning action of this special cleaning compound. We developed a rating system so we can really quantitatively rate the degree to which the mold is fouled. And this allows us then to give really a subjective measurement to the degree of protection afforded by any particular mold coating. Going further then, the method on the right, method number 2, allows us to really directly visualize the performance of the coating applied to a mold surface. Here again, we use an injection molding method, and we apply our mold release coating to a steel metal plate, a thin plate, which we apply then as an insert into the mold. So the coating is sprayed and cross-linked onto the metal plate, and the metal plate is fixed into the mold and held in place with magnets. We then inject directly onto this metal plate and force the compound to flow radially across outwards from a central injection point. Absolutely not the ideal design for a mold, but it creates a very high impact area where we inject directly onto the surface of the mold and have a mold flow radial outwards, which causes then, of course, a very high wear, a very high abrasion behavior against the surface of the mold coating. So we can then measure the degree of wear of the mold coating, and you can see that in the bottom right image. It's not really black, it's just the difference in the reflection that we see when we photograph that, and we can see the mold coating starts to fail in the central region where it's subjected to very high shear and impact from the incoming compound. Later on, after multiple injection cycles, again, we can see on the outer edges of the molding a degree of mold fouling and mold deposits. So that really gives us also a very good indication not only of the flow property with method 1, but also the durability, wear resistance, and ability of the coating to directly resist mold fouling. Next, please. Yeah, if we look then in detail a little bit more at some of the examples that we can see from method 1, the mold cleaning, if you like, and pickup of mold fouling. On the left-hand side, we have a cleaning compound after 20 injection cycles of a mold without a release agent. So the mold was a clean mold. We injected a rather mold fouling compound designed to create a degree of mold fouling 20 times and then cleaned the mold. And we can already see with our light colored, almost white cleaning compound, a degree of mold fouling at several points on that molding, where the mold flow changes direction, where the two streams come together to combine on the bottom areas. We pick up quite a severe or a notable degree of mold fouling with the dirt deposits there. By contrast, the molding, the spider molding alongside it, is 20 injection cycles of the same compound onto a mold coated with a very effective release agent, one of the products from our Structol Permalis range. And we can see for the same number of injection cycles, far less in terms of dirt deposit. And that's because the mold coating has provided an inert, resistant surface onto which the mold deposits are unable to adhere, and the deposits are simply removed with the molding. So in terms of the durability, the coating is quite long lasting. We can see number of cycles without any breakdown and without any foul. And of course, this gives us the opportunity to extend the workable time of the mold between the need for cleaning. On the right-hand side, method 2, then we can really assess, then looking at more in detail at the surface of the plate. As mentioned, the durability of the coating. So we look at on the right part of method 2, Permalis 10, one of our earlier coatings. We see no sign of any particular fouling. We can see the extent of the mold fouling, the mold flow, if you like, in a radial disc, and a slight degree of wear in the center. But by contrast, then the control compound, we can see really a buildup of black spots at the edge of the mold flow, where we see mold fouling starting to build up right at the end of the degree of mold filling that we calculated. Of course, no sign of wear in the center because we had no coating, but the absence of the coating also then promotes a very early buildup in terms of mold fouling. So that mold would require cleaning far more earlier than the coated mold. Next slide, please. So yeah, we can then carry out experiments that allow us to measure the mold coating wear rate. As mentioned, these products are applied to the mold hot, and they are cross-linked onto the mold. They are rated as semi-permanent, so they are quite durable and are expected to last multiple injection cycles. And here on the left-hand side, on the line graph, we see the wear rate of two different coatings, so compound 1 against compound 2, coating 1 against coating 2. And we can see that coating 1, for example, produced a much greater degree of mold wear, if you like, of coating wear, and was more or less 50% destroyed after 50 injection cycles. By comparison, then, mold coating product number 2, series number 2, far more durable and the wear rate significantly lower. We retain more than 80% of the coating after the same number of injection cycles. So we can really, by choosing the correct mold coating, we can have a greater or lesser degree of durability, but we must contrast that against the greater or lesser flow path that we can achieve, or flow rate that we can achieve, the slippiness, if you like, or the glidiness of the coating. And actually that behavior changes in terms of different compounds used. So if we look then on the right-hand side, the bar chart, 5 different compounds evaluated, and the subsequent wear rate achieved for 3 different mold coatings. And you can see compound 1, not so mold fouling, all coatings perform relatively well. We retain a high degree of film consistency, if you like, after a number of coatings. But contrasting that against moldings, compounds number 4 or 5, we can see then under this example that mold release coating number 3, series 3, is definitely not very durable, perhaps providing a greater degree of slip, and is more or less completely removed after the fixed number of moldings. So depending on the type of compound that we want to inject and whether we need to balance durability, the lasting, the ability of the coating to last for a higher number of cycles against the release effect, then we can achieve a different performance criteria depending on the coating technology that we choose. Next slide, please. So in terms of the practical application of these coatings, as mentioned, they need to be sprayed onto hot, clean molds. The coating is designed to adhere to the mold, to the substrate, and of course then we need specific spray equipment to achieve that. It's not so complicated as it sounds. We basically would recommend an air spray gun with a relatively fine nozzle. These are some technical drawings and information that we developed together with a leading supplier of such equipment based in Europe, based in Germany, but we're aware of equivalent equipment available globally. And as part of the service that you would get from any good mold release supplier, they would also recommend, of course, the correct mold application methods and provide maybe links or even availability for the equipment. And in fact, what we do with our customers and our distribution partners is to provide a portable self-contained system that you see in the photograph on the right that allows us to completely separate our trial product, if you like, from the product that's in use. So we can fill in a 5 litre, 5 kilo, 5 litre, a self-contained vessel. We can pressurize it with the airline, we can adjust the pressure, and then we use a fine nozzle gun, normally typically a 0.4 millimeter diameter, in this case air-assisted gun, to spray the mold and carry out the trial. Number of extension lances are available, so it's practically very easy to reach every kind of mold and carry out trials or to adopt this kind of technology in production. Next slide, please. So one very interesting aspect that we're working on, that we're developing, is the ability of a mold coating to influence the surface appearance of the rubber that's molded against that coating. One of the ways that we can measure this is to look at a value called luminosity. Luminosity is literally the brightness that we can measure. To do this, we would use a machine called a chromometer, and you see the portable handheld machine there. And we're measuring a 3-dimensional color space with the L value being the luminosity on a black to white scale, 0 to 100. So we would have a complete absorbance of light, if you like, to a complete reflection of the light. And when we change the surface layer, when we change the surface topography, if you like, then we can impact or directly influence the shininess or the glossiness, and therefore the reflection, the brightness that we can achieve on from this surface. One maybe good example is to look at a very highly polished new car. If you're ever lucky enough to own such a car, you would see then that the very smooth and flat surface would produce a very bright appearance. The light is reflected very orderly, and we see a high degree of shininess or brightness from those colours. And if we contrast that to some of the matte surfaces that we see on cars that are also becoming popular now, this is achieved by applying a foil onto the surface of the car. And this foil is a very irregular surface. The colour is the same. You can have black, and the black is the same, but it looks now very matte because the light is directly interrupted and reflects in a non-uniform manner, and we simply see that as a very low shine. So if we could apply the same behaviour to the surface of the mould, perhaps we could also produce then shiny or matte surfaces of the rubber articles in contact with that mould. So this is something additional to the quality of the surface of the mould, if you like, to directly change the aesthetics of the moulding just by altering the surface appearance on that moulding. Next, please. And indeed, to some extent, this is really possible to do. We can see here, looking at two different surface coatings, number 2 and number 1. Microscopically, they look very different. Number 2 looks a smoother coating, whereas number 1 has some interruptions. If we measure the L values, we can start to see quite different behavior in L values, and compare that to pure carbon black, which has a very, very matte and non-shiny appearance. And then looking at the bottom right of this image, we can see two rubber sheets that were molded against metal plates with these different coatings applied to the metal plates. So on the left-hand side at the bottom, a very matte rubber sheet where the surface has been a little interrupted and we don't see a surface reflection, compared to at the bottom right. Now we see a much shinier, glossier surface, if you like. This is nothing transferred to the surface of the mold. This is simply a different coating behavior, a different microstructure of the coating, resulting in a different appearance on the molding subsequently produced against that coating. So it's a newer technology. Some of our rubber molders are really interested in this, the ability to improve or change the aesthetics of their parts, as well as have all of the mold release attributes for such coatings. And it's really something that we have as a major development project in our hands, in our technology, if you like. Next. So pulling all of this together, I don't mean to go through the range of products that we have. There's a chart here, a nice selector chart, and by all means, please browse through that. And if you have questions, reach out to us. We're very happy to answer. Just simply to use this chart to highlight some of the key properties that I've talked about and that are attributes, if you like, for semi-permanent mold coatings. We talk about durability of the release film, and you see the central column, if you like, with the horizontal bars. This is the ability of the coating to withstand multiple moldings at different temperatures. And some coatings are more effective or less effective at different temperatures. Some of the latter coatings that we've produced, more recent coatings, are much more flexible in terms of the wider range of molding temperatures and their ability to remain durable both at low and high temperature molding applications. We must, however, compare, or if you like, contrast that against the sliding effect. Some mold release systems really are needed to provide a release for very sticky compounds, or for those molds where we have complex geometries and undercuts, where we really need a slippery or sliding, gliding surface in order to provide release. And quite often, the harder, more durable coatings don't provide that degree of slippiness. And we can see that, for example, with our Permalise 200. Very durable coating, but not so much of a sliding effect. Other coatings can really be optimized to maximize the sliding effect by changing one of the polymers within the system to provide a more flexible and slippery polymer. We can really aim to optimize both the durability or provide a very high degree of release and sliding effect for those more complex geometries or sticky compounds. You'll notice that water-based systems are really predominant now, and I would say that's very much the way the industry is going. The hydrocarbon solvent-based systems are still available, and they have their place, but very much water as the carrier system for these ready-to-spray systems. And a number of the products are designated as instant curing. So you'll see that with the green marks on their product description, if you like. Instant curing means that we no longer have to take into account so much the time after spraying before molding. Many products in this sector will say apply to a hot mold and then wait 5, 10 or 15 minutes. This is necessary for the cross-linking of the coating in order to achieve the higher state of cure and the durability. Instant curing technology changes the cure system and the catalysts that we have in place and reduces that very much from multiple minutes to 1 or maximum 2 minutes. So in the time that the mold coating dries on the mold, more or less that coating is ready to use. This, of course, avoids a loss of productivity and takes up one variable where the operator perhaps doesn't always wait and achieve the higher durability. So it's really an advancement, if you like, that produces a more uniform behavior in the coating. Next slide, please. Yeah, so to summarize really what we have, Permalise semi-permanent reactive systems, our Permalise range are cross-linkable systems. They cross-link onto the mold surface during the heating of the mold. Water-based products together with spray and go instant curing are very much to the fore of the technology. Coating can be very durable, so you can get long-lasting films with a reduced need to reapply. Mold flow, release, and mold surface protection are all key attributes that you could consider when using a mold coating. And indeed, it's also possible to enhance the surface appearance of rubber parts by using such coatings. Next slide, please. So a few words really on the mandrel release agents that are available. Mandrel release agents are lubricants that are designed to allow the shaped hose molding process to run efficiently. Here's a very early photograph of what we're talking about. The uncured hoses must be fitted onto mandrels in order to be cured in the autoclave. We need a lubricant to allow the hose to be pushed on, and later after curing we need the same lubricant to provide the release effect to take the shaped hose away from the mandrel. Next, please. Again, a product selector, and again, I don't want to go into details with products, except to say that it's very important to have products that are tuned to the polymer, the polarity of the polymer, so that they don't swell or penetrate into the polymer. They're not so compatible that they would damage the polymer in any way. Traditionally, conventionally, if you like, the application, the way of using such liquid-based lubricants is simply to dip the end of the hose into a bath and to push it around the mandrel. More recently, there are much more efficient automated application techniques that involve spraying a measured amount of the lubricant into the core of the hose directly on extrusion. And for that reason, you need some kind of paste or gel product, which either undergoes thermal softening or shear thinning and can be dotted down the surface of the hose to provide the release built into the hose prior to fitting on the mandrel. Also, these products should be biodegradable. The hoses have to be washed after production to remove the release agent, and it's much more preferable to have a biodegradable, easily water washable product so that the washing water can be disposed of as normal water and not treated as a classified wastewater. So the degree of biodegradability should be as high as possible in order to perform well with such a product. Next slide, please. So yeah, we can offer, and indeed on the market there are a number of mandrel release agents for shaped hoses. These products are considered to be silicone free. Silicone is absolutely not required on the inside of automotive hoses. High degree of thermal stability. We don't want the release agents to cause mold fouling on the surface of the mandrel. Certain corrosion protection systems may be built in to protect both the mandrel and the autoclave from the degradation that might occur. We match the lubricant, or the lubricant should be matched to the rubber so it doesn't swell and therefore doesn't damage the surface appearance. We expect them to be easily removable. And of course, the operators have direct contact with that, so they should be non-toxic, safe to handle and not irritating to the skin. And finally, as mentioned, then we have newer technologies where we can spray these lubricants directly into the mandrel, into the pose during extrusion, and we can remove the dipping process completely. So that's just an example of the complexity of the operation with the wheel chart there, how we can select products according to polymer and end-use application. And indeed, it's a very advanced sector of the market, I would say. Next slide, please. So yes, in summary, these products really are designed to improve productivity, so they improve the installation of the hose onto the mandrel and therefore reduce the downtime for mandrel cleaning. They eliminate mandrel fouling, easy to wash off, and the newer application methods reduce the consumption. We can really optimize the dosage in terms of how much mandrel release we need to apply per hose. And as mentioned, the products should all be biodegradable. Yeah, next slide, please. So changing the topic a little bit, odor absorbers. So I'd like to talk a little bit about some of the additives and the technologies that are available for reducing odor and eventually, ultimately, also VOC components. Next slide, please. So odor absorber additives, we really want to remove some of the malodors that are generated during processing and post-vulcanization from a variety of organic components that we find within rubber articles. So we know that these VOCs, these volatile small molecules, can give rise to unpleasant odors. Even in the absence of unpleasantness in terms of malodors, then we see unwanted effects such as fogging, the deposition of these VOCs, these fuming materials onto surfaces such as glass. For example, in the automotive industry, then fogging is often discussed in terms of the deposition of all kinds of volatile materials found in the cockpit. And of course, the VOC components in a great number of instances can be considered quite toxic, depending on the type of VOCs that we face in the polymer industry. Previously, the attempts to work on this, at least from an odor reduction point of view, have largely involved masking the bad odor with some kind of additional odor, a fragrance, if you like. So we would say these are odor masks rather than odor absorbers. Whilst this might give you a more pleasant environment, ultimately we would get an increase in the overall VOC. So we would have the bad odor and an additional pleasant odor, if you like, perhaps something like vanilla essence or peppermint oil or orange oil, which would additionally contribute then to hopefully an overall more positive smell, but the VOCs would be higher. Really, to combat this issue in a different way, we have odor absorbing additives that are able to trap and neutralize many types of VOC materials using a chemical lock and key principle. So in this way, both the bad odors and the overall VOC content could be reduced. Next slide, please. I'd just like to share with you then an example of a couple of products that were developed early on in our range. We have a pastille product and a powder product. The pastille product is designed with a relatively convenient dropping point, 85 degrees C, so quite ideal to be used in mixing. The carrier system within our pastille product also acts as a processing additive, so the normal lubrication and viscosity reduction could be expected. On the other hand, then with the powder product, we have a carrier system based on an inorganic material, and the inorganic material, a zeolite type product, if you like, offers an additional ability to absorb odors due to the porous nature of that powder. So we have two different approaches with two different chemical and physical combinations of products being available. Next, please. So yeah, I'd like to share with you then just one application example, one of a number that we're working on. And this is reduction of odor generated in a peroxide cured EPDM compound. EPDM compounds can regularly, it's quite common to cross-link them with a peroxide cure system. In this case, for example, DCP, dicumol peroxide. And here quite often you'd also find a co-agent used to boost the peroxide of the cure system. In this case, the example that I'll show you shortly, we have TAC, trialyl cyanurate, as a kicker, a co-agent, if you like, to accelerate or to maximize the cure efficiency. And then a medium level of carbon black and oil loading. This compound is known to generate odor immediately after curing, and a certain level of odor is noticeable for several days following curing in the volcanisate. So yeah, with next now, please, I'll jump into what we did with the additives and the numbers that we could measure. So this is our formulation. We have the EPDM, we have a normal, in fact, even quite low level of carbon black and paraffinic oil, the TAC and the peroxide, the co-agent and the peroxide. So a very simple formulation. And then we test the two different additives, the pastille product, if you like, the lubricant product, and the powder product, the inorganic or the dual action product. And you can see right away the effect on the Mooney viscosity. We're measuring really small. So the lubricant product, compound number 2, has a reduced Mooney viscosity, 5 points lower Mooney viscosity, and with a smaller reduction when we have no additional process additive effect. So we went down only a couple of points in Mooney viscosity. It's important that we know that these additives remain in the compound. We know the VOCs is a surface action, of course, a diffusion action, but we don't want the lubricant or the active components of our odor absorbers to also migrate to the surface. So we assess that there's no blooming in the uncured compound with or without the additive. So we have then good compatibility in the rubber. Next. So one of the test methods that we can use is a method called VDA 270. VDA 270 is an industry standard, if you like, that was adopted by the automotive industry and is used to assess all kinds of components and chemical combinations in terms of their odor generation. It is literally a nose assessment test. So you would have a glass bottle of defined dimensions, and you would place your sample in there and allow the odor to permeate into the atmosphere in the sealed glass bottle, and then have a number of people rate that by literally smelling, nosing and smelling that. And then we have a scale from grade 1 to 6, where we would say the first 3 grades are okay, starting to build a little, but okay. Grade 4 causes some concern, and grade 5 and grade 6 are really more or less unacceptable. In carrying out this test, and we carried it out a number of times and even sent it to an external accredited laboratory and arrived at the same numbers within the same rankings, if you like, we can see the 3 compounds behave quite differently. Compound number 1, the control compound, goes from a concern level to a red level between the time 3 hours to 24 hours after placing in the sample bottle. So we have a concern to a unacceptable rating. Whereas with the 2 different additives, the pastille additive as a part odor absorber, part lubricant, we go from acceptable to concern. And with the dual acting product, then we remain within the acceptable low odor range over all of the test times that we measured. Next, please. So really just summing up on these products, we can offer, and it's possible with the product technology to have pastille products which are easy to use with a good melting point, acting both as odor absorber and process additive. So we really capture the odors. We've not generated additional odors alongside the known odors or VOCs. Product clearly compatible with peroxide and sulfur curing systems, and as mentioned, acts as a process additive to reduce the viscosity. By contrast, the powdered product acts only as an odor absorber, doesn't really contribute towards processability, but having in fact a stronger odor absorbing characteristic or potential. We certainly led to a reduced odor compatible with a wide range of polymers. And we would say in this case, the carrier system assists incorporation, if you like. Although we have a reduced softening effect, the powder of the carrier, the powdered nature, also enables us to mix it more easily alongside other fillers in the system. Next, please. So these are really part of a wider range of newer products and in fact still in development products. And we aim to offer products which can act both as odor absorbers and process additives with a range of melting points suitable for different technical applications. We know not only the rubber industry, also certain thermoplastic elastomers, and even in recycling and reprocessing of elastomers, where the subsequent breakdown of the polymer may lead to more VOC and odor generation. There is a growing need for such products. So we have a range of several commercial products and some development products with higher melt points, and indeed even products where we can offer both the absorbing and masking technology. Having said that the masking technology is not ideal, we do understand that actually there's still a tendency or a preference to have a certain level of odor in some products, a positive odor. So we can combine both the lock and key and the fragrance technology, if you like. Next. So it's just an example of some of the applications, the projects that we're working on and that I would argue are really suitable for this kind of technology. Post-consumer waste, so processing all kinds of polymers. Here in this example, then disposable drinking bottles, for example, PET bottles. They're never completely clean, and the need for applying higher temperatures in the reprocessing generates odors and VOCs, and there's a demand for odor absorption in this technology, and these products look quite promising. The WPC market, so using wood flour as a filler in, again, reprocessed polymers, polyethylene and PVC for extrusion products, generates a degree of VOCs that can be reduced. Bottom left, of course, the very well-known in-cockpit glass fogging due to all kinds of volatility from the new polymer components, not least the sealing systems within the car, of course, the sealing profiles, and perhaps then a reduction of VOCs can offset that. Applications in the flooring industry, for sure, high surface area, and then VOC and migration, evaporation of materials. An interesting application with natural rubber. We have a number of companies talking to us about reduction of odors and malodors for processing of natural rubber. The mastication process, the high temperature processes produce that typical natural rubber breakdown smell, and there's the potential to reduce that odor in some markets, some applications, perhaps by using this technology. And then finally, of course, the extrusion application that I mentioned earlier with an EPDM profile, for example. Next. So yeah, to conclude the talk really, and at least this part, odor absorbing additives are available. They're quite innovative in terms of their ability to capture small volatile molecules with this lock and key principle. There are different types of odor absorbing products on the market. Not all of them are in the suitable physical forms for automated processing. So we are quite pleased that we're able to offer pelletized products. We have the access to this dual action technology, so both to absorb and mask odor if necessary. For sure, VOC emissions are reduced, not only malodors, but all VOCs are reduced. And we really target a wider range of applications with different polymers and recycling applications with the number of products and forms and melting points that are available. Yeah, next slide, please. So with that, yeah, I would really say that brings me to the end of my talk today. And for that, thank you for your attention. If there are any questions, I'm more than happy to hear them. Perhaps we hear them in the subsequent discussion, or by all means, please reach out to us via our website or the usual well-known social channels. Thank you very much.
Okay, thank you, Colin, for the excellent presentation. Okay, now I invite Mr. E. Parinathan and also Dr. Hans-Joachim Graf to join us for the discussion session now on the topic related to the mold releasing agents and odor absorption for the rubber and tire industries. In this discussion, it's not only about what Colin has presented, but I'm also asking you to discuss about all the related issues, with the mold reagents and also with reference to those smell problems in the rubber product. So now stage is yours. Dr. Graf, go first.
Okay, good evening or good morning or wherever you are. Colin, my first impression when you discussed coatings on the mold was that I have seen that the thickness of this coating, if it's, let me say, sprayed by hand, varies, and that sometimes leads to a problem on the molding. Can you comment how we ensure, let me say, that thickness is more under control? For example, automation, or this might be a solution or whatever.
Sure, thank you. It's a very good question, and it's a very, very accurate observation. I would agree with you. There's an old adage, at least in English, that says less is more. And actually, in this case, really, I'm a sales guy, but I'm a technical sales guy. And as much as we like to sell more, we prefer to sell the optimum amount. And indeed, you're right, too much coating is maybe even worse than too little coating in some cases. We've done a lot of work to measure the optimum thickness of the coating, and it's somewhere between 10 to 15 microns. But you're absolutely right. How does an operator judge when he's at 10 to 15 microns? This is really something of a challenge. What we aim to do is really good operator education. So we really start with, as I tried to bring out the right kind of technical spray equipment with a fine nozzle where we can atomize the spray and not have this sputtering, if you like. So to have uneven droplet size that we can produce with a fine diameter nozzle, then the required more uniform spray pattern. And then a degree of operator education and training, which we're also more than happy to do through demoing the product to working together with the introduction of the product. Ultimately, you're absolutely right, automated spraying. So the companies that we work with the spray equipment, I showed some very basic spray equipment there that can be used for trials. They do produce and install increasingly complex automated systems where you can have nozzle actuators and controlled spray systems to really dose the amount of release agents required. We did some work with some tire companies who were interested in spraying tire sidewalls, and we really measured that for a typical passenger tire sidewall to coat a mold, you're using less than 10 grams of product. It's really very less product used, for example. And so it really is less is more and sprayed quite evenly. Yeah, they're quite the modern products are quite forgiving, I would say. Actually, they tolerate a degree of variability in the thickness, but ultimately overspraying and respraying, we really have to educate our operators not to spray too often and not to spray too much per coating. It really, in the best case, we aim to have coatings that could be applied once a shift, let's say for infrequent molding. So our tire industry customers go for something like 1 time per shift, for example. More repetitive moldings like injection moldings, a good coating should give you at least 50, if not something like 100 injection cycles before it would even need to be reevaluated for spraying. If we're not getting that number of cycles, then there's something wrong either with the application of it or the coating itself. So this is the kind of areas that we would aim to work towards. But you're right, coating thickness is one of the keys to the product.
Mm-hmm. Is there any influence of the type of steel on the coating? In German is
carbon content or the purity of the steel, for example, or if we use a chromium plated mold or a nitrided mold. Not so much, a minor influence. The greatest influence by far, and actually I didn't bring it out in my presentation so much, the greatest influence by far on the performance of the coating is to have a clean mold. These coatings are not compatible with other kinds of deposits on the mold. So if a customer is transitioning from a silicone emulsion or some kind of oils or even an anti-corrosion coating on the mold, it's really important that we clean that off. We want access to the substrate directly so that we can bond to that substrate. We don't bond very well to silicone emulsions or other organic material on the surface of the mold. So the number one reason why these coatings fail initially is that there would perhaps not be the right level of cleaning. It sounds more scary than it is, because actually most of the cleaning methods that are in use that people would use for their cleaning, so some kind of abrasive method, maybe some kind of blasting method, coupled to some kind of degreasing, let's say solvent degreasing or solvent washing of the mold, is more than enough to prepare a mold for these types of coatings. And I would say not only my coatings, but all semi-permanent coatings in general need to have access to this clean substrate, if you like.
Mm-hmm. What goes in my mind in my early life in the business? Actually, we had cleaned the mold, put the coating on, and put it in a warehouse. Yes, for months or even for years.
Sure.
Yeah, and it worked out best. Yeah, some people still put oil on it, and you need to remove that before start. Yes, we were able to put the mold from the shelf, put it in the machine, and run the show. So that was very convenient for the mold shop.
Sure.
Yeah, maybe you add that point.
Absolutely. One of the points, actually, it's mold protection system. So we talk about mold release agents, but actually it's a mold protection system. And indeed, for storing molds, then really these products are ideal because they're very inert. In fact, some of those metal plates that we have them as demo plates, and our lab gives us new plates, but I prefer the old ones because the old ones really show the uncoated side becomes corroded. You know, everybody wants to touch the mold plate, so we get pretty quickly on the uncoated side corrosion, but the coated side remains really absolutely sealed and protected. So yeah, it's also really a good point. It should be mentioned more in the presentation. This is a way of storing molds for sure. Yes, thanks for the tip and the recommendation.
Okay. So, and then, yeah, I have still the the dosage, the thickness of the film.
Mm-hmm.
And our experience was actually that the first shot or the first two shots, there were parts with failures. Yes, so we waited then, and then you have this excess washed away by the compound in injection molding. Yes,
Mm-hmm.
compression might be different, and then you can run further. In a way, you have that envision in with your products. So that is an observation,
It's also,
which has something to do with the thickness, of course. Yes, when we talk about excess, yes, as you mentioned, we have too much on the mold. Yes, so that's.
yeah,
I agree. That's education. That's
that's
as a comment.
yeah. It might also, it's also a good point. It might also be due to the cross-linking of the film. So we set out a number of years. We set out to increase or to reduce, if you like, the time for cross-linking. So to increase the cure rate, if you like, of the cross-link system that we had in our system in our coatings. And one of the targets was to really primarily to remove this variable time. So somewhere on the back of the can or on the data sheet for many products, some of our earlier products and also many products on the market will be written in small letters, please apply to a hot mold and allow a burning in time or cross-linking time, 5, 10, 15 minutes at XYZ temperature for optimum film. That's fine, because when the sales guy shows up together with the supervisor and they do the trial, everybody's 5, 10, 15 minutes. Okay, let's mold it. It looks good. You hand that release agent over to the production, and in the night shift, somebody's saying, 5 minutes, molding, I'm behind schedule, let's run. And then the coating isn't fully cross-linked. It's not very hard, and it's destroyed with the first molding. So the shear force that you have with the first molding, particularly injection molding, cracks the film. It damages your first molding because some of it then interrupts the surface of your first molding, and it exposes the surface of the mold because we removed or in a way interrupted the regularity of the coating. So we aimed to really say, okay, can we remove this variable, or can we reduce it down from XYZ minutes to maybe a couple of minutes? And we could. One of the things that we discovered in doing so was that the coating produced with this very fast cure rate became more durable. It was more wear resistant because the state of cure also seemed to change somehow a bit. So we then said, okay, now we have coatings that maybe with this instant cure technology are not so slippery, because actually it's not one polymer, it's several polymers, two polymer systems actually. One is cross-linked to a very high degree, produces almost like a honeycomb structure, which is the backbone, the skeleton, if you like. And then there's a second polymer system with fewer cure sites, which lives as a flexible polymer within this honeycomb layer, which provides the slip action. So we then realized, okay, we have to adjust the ratio of our two components or our two different slip to increase the slip action, if you like. So I can well understand or well imagine the effect that you mentioned, and it might be that the product needed a little bit of modification for that particular application. We know the automotive industry is very concerned. They don't want silicone on their parts, and we carried out really elemental analysis with the coatings when they're optimally applied to the mold, really elemental analysis on the first molding, and we found there's no more silicone on that molding than is present in the atmosphere or on a molding that was never in contact with silicone, if it's done right. But there are doors and there are options for the thing to go wrong. Yes, I fully agree. And if the coating is not optimized or the process was not matched, the coating was not matched to the process, there are possibilities that an uncured or incompletely cured coating can transfer. That's also one of the risks, if you like, one of the things that we have to work with as technicians to minimize that and to educate the operators accordingly.
Yippee, would you like to add? Can you unmute yourself? Unmute yourself.
That's nice discussions. And here, how about the mold? Some interior portions. How do we reach for the optimum spray? Because sometimes they reach very closer to the mold and spray excess. Always the first lift, they will get all powdery. Wherever there is a joints, we get some powdery appearance coming. So as Dr. Graf explained, the first lift will always be a scrap. So we have to throw it out because there will be a lot of joining marks of the excess material coming in. Since the molds are complicated, how do you avoid this?
Yeah, actually, if the coating is really cross-linked properly to the mold, there will be no joining problems. There will be no transfer at all to the first molding. But you're absolutely right. Reaching the complex areas of the mold can be challenging. I'm a rubber technician, but I've seen some of the engineering designs of the spray equipment where you can have radial 360 sprays and really very, very complicated geometries of the spray patterns that you can produce with some of this equipment so that you can really fill and spray molds very accurately. Provided this coating is applied to the mold and cross-links properly to the clean mold, there will be no transfer. With the proper coating, there will be no transfer. And there's no reason, honestly, gents, there's no reason to scrap that first molding. Keep it. It's a good one.
Okay. Apart from this, what is the influence of our various type of polymers? For example, a polyacrylic ACM with a chlorine-based ACM, which is predominantly used in a condition like India. What is your recommendation of the coating thickness? What kind of a precaution measure we have to take depending on the aggressiveness of the polymer?
We don't really see a problem. Some polymers are inherently more wearing of mold coatings than others. So this frequency of reapplication will be different according to the end use application, depending on also the friction forces generated. So the filler, our tire guys get very excited with lots of silica, which destroys mold coatings fairly quickly as well, can be a problem. The thickness of the film doesn't need to be adjusted according to the polymer. So if we have a more aggressive polymer, if you like, with halogen generation or whatever, we don't need an inherently thicker film. The film is chemically quite inert to that, so we wouldn't see particularly a problem. Where the polymer is more known to be sticky, so if we have halogens generated, then we would expect more chemical interaction with the mold, or maybe there's an inherently more sticky compound because we have resins or other things in the mold, or the geometry of the mold means that we have sticking. Then we might need to recommend a release agent that has a more slippery surface. So we can tune that because of the components that we have. We have a more slippery polymer or a very rigid polymer. We can give a product that matches that so that you get a more sliding effect. And even if you want to improve mold filling, for example, as much as I like to promote additives in the compound, actually additives on the surface of the mold can reduce the friction enough to maybe fill the mold. So this is also a technology that's possible. But the type of behavior of that coating should be fairly consistent. Once we match that to the polymer, we don't really need to change that. But you're right, different polymers or different applications might need different products. And that's really one of the reasons why we have a number of products available. And you will find a range of products talked about. So they are tuned for different end use scenarios.
So this mold release agent is biodegradable. So what is your advice for the manufacturers on the spot life? How long they can keep, and if it is in the tank? Any idea? You can throw some.
So we have fairly fixed shelf lives. So actually, some of our more recent products, we've managed to extend the shelf life. So 12 months, if you like, for product is easily possible now. Even for highly reactive products with the instant cure technology, we still have 12-month shelf life. We would always, and again, it's education, if you like, not to tip used product back into unused product and to keep the drum sealed. Of course, general good housekeeping practices. If we can adhere to that, if we can follow those rules, then there's no real problem with the pot life. There's no stirring to do. There's no dilution to do. I know it's tempting. The procurement guys will tell you, put 50% more water in. Water is not a release agent, gentlemen. It just gives you a thinner film. You need to spray more. The products are really optimized, ready to use. So provided that's done, then we have absolutely no reason to stir, to dilute, to remix. The product is really and I would really say openly from all suppliers that I know, the leading suppliers, they have optimized products, and these products are delivered on a ready to use basis, if you like, and on different sizes. So we go from small one-shot aerosols of such products. You can buy water-based aerosols, in disposable aerosols, even for water-based products. You can have 5 litre for small users, right up to 200 kilo drums, which are connected to an in-house delivery and spray system for high volume users. And so this is where they have the same release agent piped to many machines, for example. This is also completely possible.
Once they taken to the drums how long they can keep it open if they take it to the line?
The drum should be matched. I mean, I wouldn't recommend people buying a 200 kilo drum and keeping it and using it over the course of 12 months, let's say, opening progressively. Then we would want to sell 5 kilo or 25 kilo. The drum, a fresh drum, will last 12 months. That's no problem at all. Opening the drum, there will be, of course, then a small loss in shelf life, and that will eat more into the product. When we have people who buy the right quantity, let's say, so if they're using some 100 kilos a month, they might be on 25 kilo drums, for example. We never come across problems. When we have people using several hundred kilos and they buy 200 kilo drums, not a problem. And even small 5 kilo ones for then the smaller users. So multiple opening and resealing of the drum is, in our eyes, not an issue, as long as this doesn't run over several months, let's say. If a drum is used within a month or 2 months, I don't think that's an issue in general.
So here there's some so one practice, some people blend your silicone emulsion also along with this mold, that is mandrel release agent. What's your comment on that?
Okay, in the mandrel release agents, okay, in the molds, in the semi-permanent products, the silicone emulsion is absolutely a no-no in that, because it will. Then, if you're going to do that, please don't buy the semi-permanent ones. Just buy the silicone emulsion. Honestly, because it's, much as I like the sale, you're really killing the cross-linking in the mandrel. In the mandrel, yes, you're right. Actually, so we have a real target, if you like, to be silicone free, because our end user customers, the automotive industry, don't want any silicones in that. But I know of some tricks and things where people say, okay, we have really a problem molding where we want really to have problems. Normally, it's not necessary to put any silicone in those mandrel systems. We have enough different products now available also for specialized polymers that can provide enough release effect. Generally, it's also the case when people try to dilute those products. One of the problems is that when you have water in there, those mandrels are all above 100 centigrade. So as soon as you put water in the mandrel release and you fit that mandrel release comes in contact with the mandrel, you see foaming. That's not the mandrel release foaming, that's the water in the mandrel release foaming, and the water evaporates, but it leaves the mineral deposits in the water because you didn't use the ionized water, you used normal water. And so you leave some minerals on the surface of the mandrel, which starts the fouling, and then some interactions between the mandrel release and the mandrel, the deposits on the mandrel. So again, it's clean mandrels, no dilution of the products, except in a few cases where we really can recommend that under controlled conditions. And we would say no need for silicones in there, because this is a different technology. And it's really, really, really difficult to remove all the silicone. Once you have silicone in your hose, you will have silicone in your hose at your end customer. So it's a risk that the customer will not be happy with that.
Mm-hmm.
And of course, you impact then the biodegradability, because you're absolutely right. You have silicone in the wastewater then, because you wash the finished hose and you put some silicone in. So probably the local municipality will come knocking on your door at some time and say, "Hey, you're depositing silicone in the water treatment."
Right, you're right.
But I know it's a point, and it's also a point where, you know, we talk about how often can these products be used, and once you have a stable product, I mean, a lot of that mandrel release in the traditional sense, where they dip it in a bath and they put it on the mandrel, and then when they demount, a lot of the product runs back in. It's really stable product. It doesn't degrade so much, and so it can be used multiple times. It's quite an efficient process when you have the right product for the right application.
If I
have anything to suggest the spray gun? The spray gun is a very important issue. Do you suggest anything? Because normally they say take a paper and then spray. There should not be water droplet falling. Is structural would like to have some sort of some calibrator to calibrate the gun.
Sure. We worked very hard with a German-based gun producer, so Schutz, Alfred Schutz, if Dr. Graf is familiar with those. They're one of the leading producers of spray technology for release systems, not only for rubber, but for other applications. They have many outlets and actually many competitors worldwide, as I came to know. We have a lot of information, and we can give a lot of support on what means a good spray pattern, which kind of gun diameter. So normally around something between 0.3, 0.5 millimeter diameter gun, a gun suitable for water-like viscosity. We prefer air systems, air supported systems to airless systems, because we get a better control of the spray pattern. Our technical teams really train to carry out trials, you know, to take the sleeves and to come and make trials in the customer plants to demonstrate not only the product, but the application, how to apply, and really to work with people to get the right spray equipment in place, because you're absolutely right. The spraying equipment is as important as the product itself. You know, if you go to the local garden center and you buy to go to Obi or something, this is not working. This kind of spray systems are will not work with such products.
Mm-hmm.
Yes, sir. Yes, Graf.
Yeah, one word or one point to the gloss and
Okay.
switch in between surfaces. Did I understand right that you say with the coating you can somehow control the gloss?
Yes.
Mm-hmm.
Yes, we can. By changing the geometry of the surface geometry of the coating, we can influence then the gloss or the matte appearance of the rubber molded against that coating. Yes.
And would that be not in competition to the structure of the mold surface, or is that somehow related to that?
I mean, you can of course machine the mold surface maybe microscopically to also do that, but of course the mold deposits will tend to flatten that mold surface. So what we can do, whilst we generally say we aim to have this very smooth surface, by microscopically interrupting or changing the topography of our coating a little bit, so to have some spheres, if you like, or some imperfections or irregularities slightly in that coating on a nanoscale basis, we can start to change then the surface shine of the rubber in contact with that. So we have some tire customers in Asia who say, oh, we prefer to have very shiny sidewalls. In Europe, we're a little bit more shy, and we prefer quite matte tires without so much shiny sidewalls. And we have certain coatings in use only because the tires produced are more shiny, nothing else. Mm-hmm. And this is because of the ability of the coating to change the surface appearance. So we can, as much as we get this shiny surface, we can actually go in the opposite direction and produce a more matte surface on the rubber, so to interrupt a little bit the surface.
Yeah, a bit in my understanding, a tire is more compression molding, and we in Technique we are more injection molding. So there should be a difference, yes?
There are some differences, of course. I won't say that it's possible for every molding to radically push for completely shiny or completely matte. The surface frictions, the shear forces will also have a great part in changing the surface also, of course. But it's simply to introduce a new aspect, if you like, to the ability of the coating to provide an option for the molder. So
No, I agree that since some years, yes, rubber is also an element of design, yes, and then we talk about surface.
Yeah.
Yeah, yeah,
Yeah.
that's true. Okay, so that I found that is an interesting aspect of the coating.
Yeah, for us it's an ongoing topic, to be honest. I don't say that we have all the answers. We have some answers and we have some nice developments in that area, but I want you to share it because I think it's something that's not really talked about very much in terms of what coatings might be able to do for producers. And I think this is an interesting area which can be discussed more, if you like.
Yeah, and then you have to spray shot by shot, or you can.
You can still have, you can still have a semi-permanent, so that effect lasts. It depends on the application. Maybe that effect doesn't last as long, if you like, as the traditional coating. Maybe the geometry is a little bit more interrupted. But I can only say I'm a tire guy, a poor tire guy, and I know from the tire customers they are compression molding. You're right, and actually their surface appearance demands are even somewhat different, let's say, and not as demanding as perhaps some of the precision technical articles. That's also true. But, it's actually, I was surprised to the extent at which we can influence the appearance by just the coating.
Yeah. Okay, if there is nothing else, EP, from your side on this part of the process.
We talked much on the mold release and as well as the mander release. About the odor, I would like to have some clarification. This inorganic deodorant or odor absorber, what will be the kind of a chemical interaction with the other fillers? Will it change the pH of the total compound?
No.
Can you clarify that?
It's a relatively inert. Yeah, the inorganic component that we have in our one of our products, it's not present in most of the products, but in one option where we have a combined inorganic, organic. The inorganic one is not a reinforcing filler per se. It's an absorbent filler, but not a highly structured filler, if you like. It doesn't have a particular tendency to push the pH. It's not an alkaline, not a very basic filler, let's say. It doesn't change, will not have a big influence on the cure behavior or the reinforcement characteristics.
Okay.
So in peroxide,
how to optimize the dosage? The dosage goes from 0.5 to 15 pHi. So
we're at the start of let's say a learning curve, if you like. We have some tested applications and some established, let's say, benchmarks with that. We're aware of a huge, let's say, growing interest in this, and it takes us into sectors where we also know that the VOCs can be quite challenging, let's say. And we also have let's say, an academic partner where we're working on that, and so we really are covering a broader range of applications and even loading. So it's difficult to say what is the optimum loading for we are used to rubber loadings. 2, 3, 4 pHr is okay. When people start telling you 10 or 15 pHr, people get, let's say, excited, if you like. But it depends on what we're really trying to achieve with the end use, if you like. Maybe not in conventional rubber applications, but maybe in recycling or some other, let's say, niche applications, it might be the case.
Okay. Normally, in any polymer, when we have some amines kind of an antioxidant, normally amines are used like antioxidant, antioxidant. Then obviously we have an amine smell. We characterize the amines by the smell. So obviously it's creating odor. So how do you protect the anti-ozonal property, and also the having no smell is a challenge too. So yours seems to be a good solution for that.
Yeah, I would say we don't get to no smell, but we get to lower smell. And so it's a question of where is the acceptable or imperceptible, unnoticeable odor, if you like. We're also working on more analytical methods for that. So to have a real, GCMS, headspace GCMS, if you like, to capture the volatiles and analyze them analytically. It's also quite challenging, and there are different methods used for that. You're right. It won't actually capture all VOCs. So there are certain normally polar molecules and relatively small molecules that can be captured by this technology. Some of the amines, yes, I would say not some of the more complex amines. So it really depends on what we're looking at. The peroxide decomposition products seem to be captured quite well. So it works really quite nicely in peroxide systems. Let's say that's quite an interesting area. And yeah, it really depends on the end use. Maybe we need the combination products, and ultimately that's why we also even hedge our bets a little bit, that we have the capture and the masking technology at the end of the day. It's the more elegant way. The scientists will say, oh, capture, but the practical people will say, if the odor is acceptable, if there's still an odor but it's acceptable, then it's we live in the real world and we have to satisfy the market and what people want to have. So maybe we still need some kind of combination product.
Now I like to make a comment here. I mean, exposed to permanent odor, for example, for diving or a mask for a pilot in defense airplane, is different than you are exposed a certain time. Yes, so that's why I always avoided vanilla, because it becomes very offensive
Eventually,
after
yes.
a longer time. Yes, so we need, I think, to stick to your approach. Yes, that you say we capture the odor. Yes, and my question may lead to a hard case, and that is it possible to save post-cure time in peroxide cure? Is that, yeah, if you capture all, now you already said you reduce the volatiles, yes, which I accept. I would say yes, that is probably possible. Okay, for me that's new. This approach, so and I have no experience, so I can only speculate a little bit about. Yes, that's to be clear with you.
Sure. It's an interesting option. Real honest, straight answer. We haven't looked at it. It's something that we're thinking about, but it's something that we didn't do really detailed work so far on it. We know the time dependency of the odor generation seems to be altered. So we could see that in the, let's say, in the time after curing, or the time for the odor to be neutralized in the bottles, let's say. But really, if that allows us then to eat into post-cure time, that's something that we have to work on. I think there are a number of different processes going on in that post-cure time. Certainly to stabilize the compound from a VOC or an odor point of view is one thing. Whether it also impacts then the stability of the compound or the article in terms of its overall performance. I like the if you like, the lateral thinking or the next step generation. It's the sign of a really smart technologist, because these are the secondary benefits and the additional options, if you like, that might be possible with these products. And we are also in our learning curve working on that, on numerous things. So I can't answer your question, but it should be possible to. The suggestion is that it might do, but I also don't have an answer to that so far. But interesting, really interesting.
Okay, any other points you guys wanted to put together? Yeah. Interesting discussions. Okay.
Yeah, really, thank you. I mean, for us, the odor, the release agent business we know quite well, and we're looking for obviously new options in terms of sustainability, longer lasting films, and so and new automated application with the spraying and dosing through the extruder. But the odor absorbing technology is really now starting to be, let's say, in our greener, kinder, more sustainable and environmentally friendly world. I think this is really something. Okay, we use chemistry to neutralize chemistry, but I think that's a good way forwards, and I think more will come from these kind of product technologies.
Mhm.
Okay, thank you all, Colin, EP, and Dr. Hans, Dr. Graf. Colin, any final remarks? On both on mold release and the order, both issues together. Any final remarks?
Really, I would say honestly, thank you very much for the very lively and interesting discussion. You gentlemen really homed in on the points. I really like to debate and to discuss and such kind of this open and sharing information, sharing ideas, sharing the challenges, the limitations are really the ways that we all learn and think more about how we can make better products and develop the applications for those products. So for us, we really appreciate that and your input and your feedback. And if we can answer more questions for anybody, more than happy to do so. So really, thanks for the opportunity.
Okay, thanks, Colin. Thanks a lot. EP, final remarks on the whole presentation and the discussion here.
It's a wonderful presentation, very crisp, and also it's very relevant. In fact, the VOC is the talk of the day. In fact, many people are struggling to how to reduce. In fact, some of my projects also there where we have to reduce the VOC and the smell. And this VDA requirement is very recent. Even in India, many rubber component manufacturers are asked to do the test. The laboratory is having some 5 inspectors to smell the odor, and 3 will say not okay, 2 will say okay, and 1 will grade 3, another will grade 4. So finally, they come out to the grade 4. This is what happens here. So it's a very quite interesting topic as such with respect to odor. Now the consciousness is improving. All automotive manufacturers today, they want a validation of the VOC. All rubber components used inside the cabin should pass the VOC requirement, especially the VDA requirement of this odor. So it's a challenge of the day on which he has taken the topic. It's a good topic. In fact, by this awareness, I'm damn sure that many people will refer to the Structal for referring to this odor absorbent. We'll get many more calls, I hope, for inquiries for this odor absorbent. Good, thank you very much for this.
Thank you, Dr. Graf.
Yeah, I think all is said. I enjoyed the presentation. I think the presentation was very informative, and of course, everything what we do in the lab and have ideas proven somewhere needs then to survive in production. So then that's the real case, yes. And a little bit to smell, remind on my past, yes, there was Audi and Helga Prechtel as a leader of the development group, and for us, her nose was the target and benchmark. Yeah, and she was very sharp, and I liked she very much. And when you survive that judgment, then you were through. So if those products helping, yes, because she always said rubber smells, and indeed it smells, yes. And so capture that type of chemicals which are in the air, and with our nose chromatograph, we actually smell that then as a smell. Yes, it is just a transformation in our brain then where we will be a step forward. So that is a very interesting product family, and I hope you have a progress here in the future.
Oh, thank you.
You're welcome.
Okay, thank you, gentlemen. Really, very interesting, lively discussion. Once again, thanks, Colin, for being part of this program of the Rubber Industry NewsHour and giving a presentation on the both mold releasing agents as well as the odor control issues in the rubber industries. Super. And EP sir and Dr. Gruff sir, thank you for being part of the discussion. I think it's a wonderful discussion. Appreciate for your contribution. All three of you, thank you very much.
Thank you.
Thank you.
Okay, everyone, that's the presentation and the discussion on the mold reagents and odor absorbers in rubber and tire industries. I'm hoping that you find this presentation useful. And if you like to watch this session again, it will be available on YouTube at the Technobi channel. And as EP said, that there will be a lot of calls. I think there will be a lot of people will be viewing on this program again and again, call in. So please keep your mobile phone near to you or email address. Okay. Yeah. Thanks a lot. It's a really interesting presentation today. Enjoyed it. Yeah. Okay, guys. That's the end of the episode today. I see you in the next episode. Thank you all. Bye bye for now.
Thank you. Bye-bye. Thank you.
All right.
Bye.
Mm.